set builder notation. What do we mean by set builder notation? If we have a set, for example, C has 3 elements, let's call them, the first element is 1, the second element is 5, the third element is 6. So 1 is an element of the set C. The notation for that is as follows. 1 is an element of C. If we take 5, 5 is an element of the set C. We write the notation is that 5 is an element of C. Similarly, 6 is an element of set C. This is the set. 6 is an element of C. This is the notation. Okay? Instead of writing set is an element, 1 is an element of the set C, or 5 is an element of a set called C, or 6 is an element of the set C, we just put the notation. 1 is an element of C. Okay? 5 is an element of C. 6 is an element of C. Okay? Is an element of the set C. As simple as that. Let's have a look in other aspect. A is a set. Let's say it is composed of 2, 3, 4. So we are having 3 elements. Element number 1, element number 2, element number 3. Okay? And B is having 6 elements. Let's have, for example, first element is 1, second element is 2, 3, 4, 5, 6. So we are having 6 elements. Count with me. 1, 2, 3, 4, 5, 6. So set B has 6 elements. Okay? If you note with me that set A is 2, 3, 4, right? We are having this here. We can say that, okay, if we are having A is within the set B, we can say that A is a subset of B. In other words, we can write the notation as A is a subset of B. For example, if we take an example, okay, the set of negative integers, -1, -2, -3, set of negative integers. If you focus on the set of the negative integers, it is a subset of the integers. We know the integers are -3, -2, -1, 0, positive 1, 2, 3, and so on. Okay, so this set, which is the negative integers, is a subset of integers. We can say the set of negative integers are a subset of integers. As simple as that. Also an example, if we say the set of positive integers, or positive integers, all we know that the positive integers are natural numbers. Okay, we can say in either way, natural numbers. We can say the set of positive integers or the set of the natural numbers. So the set of the positive integers is a subset of the integers. Is a subset of integers. That is, positive integers is a subset of integers. Okay? We know also that the set of integers is a subset of rational numbers. So it can be written as integers is a subset of rational numbers. Another thing to consider is the empty set, or you can call it the null set, or phi. If you question yourself, for example, give me a car with a speed or number of cars, give me the number of cars with speed of, let's say, 2000 kilometers per hour. Do we have a car that can go with this speed? In fact, we don't have. So the set of cars, the set of cars that can speed up to 2000 kilometers per hour is empty. We don't have car that drive with a speed of 2000 kilometers. If we say the set of natural numbers below than 6, the set is represented by this. So we have natural number less than 6, 1, 2, 3, 4, 5. So we have 5 elements. We have 5 elements. So it is called a finite set. What about if we say the natural numbers? If we say the natural numbers, we know the natural numbers 1, 2, 3, 4, 5. The number of elements we don't know. It goes to unspecified number. So we call set as an infinite set. So if you know the number of elements, then it is a finite set. If you don't know the number of elements, then it is an infinite set. Now let's look at the set builder notation. If we have a set written like this, how can you read this set? You can read this set as the set of elements. The set of elements 2n. The set of elements 2n, such that n is a natural number. N is an element of natural numbers, or n is a natural number. N is an element of natural numbers. This is how you read this notation. Again, the set of elements 2n such that n is an element of natural. Now I would like you to represent this notation. Again, the set of element 2n such that n is an element of natural numbers. Okay, so if you are going to represent it, you know that the natural numbers are 1, 2, 3, 4, and so on. Okay, so 2n, what does it mean? It means that 2 multiplied in n, which is n could be 1, could be 2, 3, 4. So if you represent it, 2 multiplied in 1, the answer is 2. The first element, of course, is 2. The second element, 2 multiplied by 2, so it is 4. The third element, 3 multiplied by 2, it should be 6. Fourth element, 4 multiplied by 2, so it is what? 8, and so on. If you focus with me, you can call this set is the set of positive even integers. Of course, you know this is the set of positive even integers. Of course, you know the difference between between even and odd. Even number even number is 2, 4, 6, 8, 10, 12, and odd number 1, 3, 5, 7, 9, and so on. If we take an example, the set of real numbers greater than 2, the set of real numbers greater than 2, so can be written as the set of x such that x is greater than 2 and x is an element of real numbers, okay. Again, the set of x such that x is greater than 2 and x is an element of real numbers. This is how you read the notation. As you go through the book of algebra, we usually deal with real numbers. So in this situation, we are going always to accept the fact that we are dealing with real numbers unless stated the difference. Okay, so if it is not mentioning a real number, you should consider it as a real number set that you are dealing with. So in such a case, we can shorten the notation. This notation, we can shorten it. You can write it the set of elements x such that x is greater than 2. We know that x is a real number, so it is a shortened version of this one. Let's go through exercises. List the 4 smallest elements. First one, A. We have the set n cube such that n is an element of natural numbers. The second question, B. The set of y such that y equals x squared minus 1 and x is an element of integers. If you are going to answer this question, the first thing you notice that n is a natural number. So we know that what are the natural numbers are. Natural numbers are 1, 2, 3, 4, and so on. Okay? If we are going to pick the four smallest elements of n cube, we are going to take the 4 smallest elements in the natural numbers. So these are the 4 smallest elements of the natural numbers. We are going to substitute them on n cube. So the first element 1 cube will give 1. The second element 2 cube will give 8. The third element 3 cube gives 27. And the fourth element 4 cube gives 64. So listing the smallest 4 elements of n cube, the set of n cube is 1, 8, 27, 64. Similarly, the same question. The set of y such that y equals x squared minus 1. X and x is an element of integers, of the set integers. So we know what integers are. Minus 3, minus 2, minus 1, 0, 1, 2, 3. Okay? So if you are going to pick what's the smallest value that this y will have, we don't know. We have negative integers, positive integers. So let's start in a proper manner. So we will start by minus 3. Okay? Then we will start, go minus 2, minus 1, 0, 1, 2, 3. So if we take x squared minus 1, so minus, it would be minus 3 squared minus 1, which is equal to what? Minus 3 squared is 9, minus 1 should be 8. Minus 2 squared minus 1 should be minus 2 squared minus 1 equals to what? 4 minus 1, it will be 3. Okay? Here it would be 0. 0 here it would be minus 1. For 1 it would be 0. 2 it would be 3. 3, the answer will be, of course, 8. So we can say the 4 smallest elements of y is as follow. You can check here. We have 8, 3, 0, minus 1, 0, 3, 8. So you don't put here, for example, 3 and 3. This is a mistake. You can swap between, for example, if we say minus 1, 0, we know minus 1 is smallest than 0. You can interchange, it's okay. However, we are going to go from smallest to largest. It is proper. So what is the smallest here? It is minus 1, 0, 3, 8. These are the 4 smallest elements of the set Y.